Hi there, and in this video we're gonna be checking out Godot 4.5 Dev 5, okay? A version that has taken quite a lot of time. If we check that the latest Godot version that we got was on 13 May, so something like 20 days, and it actually has lots of interesting things such as abstract classes, okay, which is a complete game changer, and lots of other things that we're gonna be checking out in this video. Not only this, but also it is said that this is likely to be our final development snapshot of the 4.5 release cycle. So indeed, Godot 4.5 is closer than ever before. So first of all, we are now gonna be having native Vision OS support. If you know what Vision OS is, it's basically Apple's XR environment. So once again, Godot just making some improvements in everything that has to do with XR. Once again, not really gonna be covering this a lot since it's something super specific for super specific Godot developers, something that will affect all of us basically, in spite of what exactly we use the Godot engine for, are for example abstract classes. You may be familiar with abstract classes if you have used previously Unity with C#, for example. So now we basically have the new abstract keyword. So if we want to make this class an abstract class, well, we basically use this syntax, and then on ready we can kind of create this new class in other script, for example. And here it's not kind of well explained, or it doesn't actually tell you the actual advantage of this, so I will try to demonstrate it in this video. If you actually want me to create a full guide on abstract classes on Godot in this new version, let me know and I will create it, because I do think that if this works similarly to how it works in Unity, for example, it's a complete game changer. Because here it tells us, okay, the purpose of an abstract class is to create a baseline for other classes to derive from, and here we have another example of kind of inheriting this class, or actually, well, creating a new class that extends from this base class, or super class, you can also call it. And here you can actually see it. You have your kind of parent class, and then you have children, okay? So, but it doesn't actually mention like the advantages of this. Once again, we're gonna check them out as much as we can in this video. For those who are into shaders, we now have shader baker exporting, which is an optional feature that can be enabled at the export time to speed up shader compilation massively. Basically that. Once again, something not too general maybe for the general Godot user, but if you're really into shaders and your project has a lot of shaders, well, maybe this option does really help you streamline your flow a little bit. There are also some changes, once again, in the web builds, but once again, I don't really understand this because I don't really build a lot of games to the web. I am not really informed about that either. But in general, once again, I don't think it's a very big game changer for the general Godot user. Of course, maybe if you are all the time into web games and all that, you'll read this and you can tell me in the comments, oh, this really changes this or that. Once again, if whatever here I'm not mentioning and you do understand what is going on and you do think it is important, just kindly leave it in the comments so that we can all learn and take advantage of this. Then we have another maybe small additions. We have now inline color pickers. This is something that you have, for example, in Visual Studio Code. I don't remember if in Visual Studio Code it was with an extension that I had downloaded like as soon as I started programming, or it was kind of natively incorporated inside of the VS Code, but it's pretty similar how it's gonna work. Some improvements in the renderer of Godot. We have off and on, well, with different technologies that have been implemented, okay? And usually, and as usual, sorry, we have even more stuff, okay? But well, I believe that with what we have already mentioned, I believe that the most important thing is maybe abstract classes, so that's what I actually want to check out. I'm in incognito, by the way, because when I wanted to open with a browser that wasn't in incognito mode, I wasn't able to kind of load the Godot website. I don't know what happened, but anyway, just for you to know that. So let me go over here. So here I am, as you can see, 4.5 Dev 5. So the first thing I want to check, which is the easiest one, is this thing of the colors. So yes, pretty easily we could create here a new script and just create a new, I don't know, base color variable, for example. Let's call it base color, okay, and let's make this equal to color. And I know it's like this. Yes, now the things that you can directly pick it over here, so you don't have to type it manually, or even previously maybe you need to export this variable and set it in the inspector. So now you just save some time with this. Once again, small additions, but that they are exactly that, small additions, okay, nothing too crazy. So what I really want to talk about is abstract classes. So once again, how this would be useful, okay, is let's say that we have different obstacles, okay? This is quite related to inherited sins. Once again, inherited sins are not a topic that is usually covered. I am preparing a tutorial or even a full course on inheriting sins, and now with abstract classes, this is really kind of powerful, okay? Once again, if you're familiar with things such as C# interfaces, C# abstract classes, and C# inheritance in general, you understand where I'm going. If you have never used that, if you have never had those issues, maybe it's not such a huge game changer, okay? But let me tell you why this is important, okay? I will actually go to a previous project from one of my Godot courses, okay? Link in the description down below, which is basically this 3D obstacle course game, okay? It's basically that. It's a 3D obstacle course game, but it has some obstacles, okay? So this is the game, okay? It's pretty simple yet complete, okay? You have everything that you need in order to create a full game. So let's give it a second, play game. And here it is, okay? So this is what we have. So what I want you to explain over here is that the game has different types of obstacles, okay? So let me go to, I don't remember where this was, obstacles. As you can see, and I have 3 obstacles. How this works is that they are 3 completely separate scenes, okay? The only thing that they have in common are, for example, well, all of them have an area, okay? But then they are slightly different because, well, they have different models, for example, okay? And they have different collisions, basically collision shapes, okay? Because this shape is different from this one, for example. But they still share the same obstacle script because basically their behavior is quite similar, okay? The only thing that is different is that, for example, some of these ones can rotate. Once again, if we come back to the original game, we can see that this saw is rotating. We can see that that other obstacle over there, the blue one, is also rotating. But for example, these spikes are not rotating. So how you could manage this previously was with an export. So the obstacle can rotate, this saw can rotate, the spikes cannot rotate, and this spike block can rotate. So this is a way in which you can start to see where this is going. The thing is that all obstacles have lots of similarities, but at the same time they have lots of differences. Because, well, some of them we want them to be able to rotate, some of them we don't want them to be able to rotate. However, all of them, we want them to be able to detect the collision with the player, and if they have collided with the player, well, they just call the game over function, so that is a common behavior. But you see where this is going, basically. Once again, this is a pretty complex topic, would require its own video, okay? It's even its own full course, but I want to explain at least the basics, because I also should have to research a little bit more how abstract classes exactly work in Godot, so I will just try to do something pretty simple right now. So first of all, here's how we declare an abstract class. So let me go back to Godot over here. And so what I will basically do is just create a new script over here. Okay, which I'm gonna call here abstract. Basically a folder, sorry, and here I'm gonna create a new script just to make it differentiate from the others. And I will call this one base obstacle, okay, for example. Here we have it, base obstacle, okay? And here we have to make it abstract, okay? So let me make it abstract with this line of code. And the class names are gonna be my abstract, it's gonna be base obstacle, for example, okay? So now what we should be able to do is to inherit from this class in every single obstacle. So once again, in this case, they all share the same obstacle script. But the thing with this is that each obstacle could have its own script. So spike, block, wide. And what we could do is everything do it directly here. Let me show you this. So I will actually copy all this or cut all this. Let me go to base obstacle. I'm gonna do all this. Okay, now we have problem because body enter. Yes, because it extends node, not area 2D. So what I will directly do is to right over here, create an onReady to the area. So onReady var area. This is gonna be of type area to 3D, and this is gonna be equal to the, well, once again, I don't really know how this exactly works in Godot, but here that's not really what I wanted to. So I believe here we should do something like area to 3D dot body entered. Okay, and rotation degrees not declared in current scope. So here once again area 3D dot rotation degrees. Okay, and now in this obstacle, what we need to do is to inherit from this script. So let me directly go over here, class name. Let me go back over here and let me do it like this. So now this is extending this class, but it extends, let's call this one obstacle, but it extends base obstacle. Okay. So here we have it. So now in reality, everything's gonna look the exact same way, but you can see that now we have a base class basically, okay, with different things, okay. And then in reality, as we are inheriting from this class, we also have access to a different component. So as you can see, I actually have here the can rotate button. In reality, I believe that if we play, we shouldn't have any difference. And in reality, I believe that here, rather than doing this, what we need to do is to delete this from here. Once again, let me research a little bit more about this, and here extend directly an area 3D. I believe that's what we actually need. Yeah, there it is. Okay, so everything is the same, but now what we have is that everything is in one place, okay, in one base class. And once again, this relates to, okay, we can have different behaviors for each of them. Okay, we can have custom functions or virtual functions that then we can override in these different base classes and do a variety of things. Once again, I don't want to complicate this even more because I have to take the time to research everything to actually show you an example. So if you really want to know all about this, what you have to do right now is to take a look at how this currently works in Unity, because I believe that the implementation here is gonna be quite similar. Or just give me some days to research all this, and if you're interested in it, I'm gonna release a new YouTube video. So this is all for this one, and I'm gonna see you in the next one.